Hello, welcome to Progressive Education Society's Modern College of Pharmacy, Nigdi, Pune. In the e-lecture series of in the subject Natural Drug Technology. Myself, Dr. Bhushan Pimple. In this video, we will discuss about the in vitro screening methods and their applications for natural products. That means how to screen the natural products for their various applications or indications. First, we will discuss about the antioxidants. Antioxidants are the category wherein you can find numerous compounds in the market ranging from fruits to fruit juices or vitamins, tablets, and whatnot. So most of the owners they do uh, claim that their products are containing antioxidants, and people also consume a lot of antioxidants for various health benefits. So in this chapter we will see how the antioxidant property can be estimated in the lab. That means how it can be quantified. For that we will first see about the antioxidant activity. What is basically antioxidant? Oxidation, as we all know, it is the reaction wherein free radicals are produced in our body due to oxidation. We normally call it as peroxidation and all. These free radicals they lead to a chain of reaction that is able to damage not only the cellular components but cells, tissues, and eventually organ of the body. Antioxidants are the compounds that inhibit this entire process of oxidation, and they prevent our body from damage caused due to the free radicals. Generally, antioxidants used are thiols or ascorbic acids. They are able to terminate the chain reaction of free radicals. In simple sense, suppose this is a free radical which is devoid of an electron. It is having shortage of an electron. So to stabilize itself, it is trying to snatch away the electron from a healthy atom. In doing so, the healthy atom will lose its electron and it will be converted. It will be healthy atoms like so suppose metabolites and all, they will be destroyed. So to prevent this from happening, we consume antioxidants. Now, what are antioxidants? They donate their electron to this free radical and they stabilize the free radical and prevent this theft. In other sense, suppose this is a free radical which is missing an electron. The antioxidants externally administered are, so suppose vitamin C, E, or thiols and other fruit juices and all. Even our body also has antioxidant enzymes like catalase, glutathione, and superoxide dismutase. So these enzymes are also these enzyme levels can also be elevated by various yoga or pranayama or even by consumption of certain antioxidants. These enzyme levels also increases. Now how do these act? They donate electron to the free radical. This electron now stabilizes the free radical. This is the overall mechanism of how free radicals can be converted into a stable molecule and later on it can be kicked out of the body. Now, sweeping these free radicals is called as scavenging. Scavenging means cleaning. Cleaning of the free radicals from the body is called as scavenging. Now, these antioxidants have free radical scavenging activity. Antioxidant assay means quantitative measurement of the antioxidant potential. We use specific free radicals which are available in the market like DPPH free radical, then hydrogen peroxide free radical or nitric oxide free radical. The method for determination of antioxidant potential of phytocompound is nitric oxide scavenging assay. Here the principle is sodium nitroprusside. It undergoes a reaction in aqueous solution at a pH of 7.4 to form nitric oxides. This is a very common reaction and it is used in decreasing the blood pressure. So you can find sodium nitroprusside injections available in the market, and the injection does the same work. It enters into the body at a pH of our blood pH, that is 7.4 pH. It produces nitric oxide and dilates the blood vessels, thereby decreasing the blood pressure. Now the same reaction is applied here. Once the nitric oxide are generated in the test tube, it comes in contact with the oxygen to form nitrite ions. These nitrite ions are able to form a complex with grease reagent. Grease reagent has one inactive dye. The inactive dye requires nitrite ion for activation so that it produces a colored complex. Once nitrite ion fuses with grease reagent, it forms the colored complex. It is a dark colored complex. Now antioxidants, they compete with oxygen. That means the antioxidants, they come and block this reaction. They prevent the oxygen from oxidizing the nitric oxide. Thereby they block this red colored arrow. So low amount of nitrite ions or no nitrite ions will be generated. Since there are no or low nitrite ions, they are not able to react with, or they are not able to convert the dye, inactive dye, into active form, and low intensity color or colorless complex will be formed here. The reagents required are phosphate buffer solution, sodium nitroprusside, and grease reagent. Now, grease reagent involves sulfanilamide, phosphoric acid, and that inactive dye, that is N1-naphthylene, naphthylethylene diamine dihydrochloride. Now we'll see into the details about the principle of this reaction. Suppose this is sodium nitroprusside solution or powder, which is mixed with water to form a solution at a pH of 7.4. Now upon formation of solution, it gives out nitric oxide. This nitric oxide, it comes in contact with the oxygen and gets converted to nitrite ions. Nitrite ions, as we have seen, they are able to react with the grease reagent. In the grease reagent, it, there is sulfanilamide. Sulfanilamide forms a complex with the nitrite ion and it gives an intermediate or highly reactive complex or a intermediate. The second component in grease reagent is naphthyl ethylene diamine. Now this ethylene diamine, it reacts with the intermediate formed by sulfanilamide and nitrite ion reaction, and it further leads to formation of this kind of a complex. This gives a colored complex. This is having a dark coloration. So the test tube appears, or the Eppendorf tubes appears in this way, that is a dark colored solution. Naturally its absorbance will be too high under the UV. But in this test tube, if you have the presence of an antioxidant, antioxidants, they are able to kick off this oxygen. They prevent the oxidation of nitric oxide to nitrate. Eventually, there will be very less amount of nitrite ion formation. Since there are low nitrite ion formation, the entire further procedure with the further process with the grease reagent stops, and there will be no or low formation of this chromophore colored complex. Instead, the test tube will appear in this way. It will be colorless, or depending upon the antioxidant potential, if you have added more or if your antioxidant is too stronger, it will form a colorless complex or colorless solution. About the procedure, 100 microliter of plant extract or standard is added in the respective test tubes. The 3-4 test tubes are to be maintained: control, blank, standard, and sample. 3 ml of sodium nitroprusside is added, incubated. Then 3 ml of grease reagent is added. Then similar reaction mixture without addition of sample serves as a control test tube, which we require for the calculation. The absorbance is read at 546 nanometer, and the absorbance of blank is subtracted from this. And then these three readings of control, standard, and sample are put into the formula for determination of scavenging activity. Percent scavenging activity of sample, you need to incorporate only the absorbance of sample. Now the absorbance what you are quoting here should be initially subtract it has to be treated with the by subtracting the absorbance of blank. Similarly, for control, subtract the absorbance of blank from it and then put the values, so you'll get more accurate values. Blank is serving just like a correction factor here, or baseline correction. Now we'll see the procedure, how it is carried out. Initially 4 test tubes are taken. Now, ideally, you need for any antioxidant assay, you need to take the test tubes in triplicate. Triplicate in sense controls the 3 test tubes of control, 3 test tubes of sample, 3 test tubes of standard, and so forth, blank. But for representation purpose, we have taken one each. Label them accordingly, and to this we need to add different solutions. Initially we will be adding the sample. Now sample here in case of control is nothing but water, plain water. In case of sample test tube, we are adding the extracted or isolated sample, and in case of standard, we are adding BHT or routine. And you can notice here there is nothing in the blank. Next, you can add 3 ml of sodium nitroprusside solution. Next step is to add sodium nitroprusside because we need to generate the nitric oxide. Nitric oxide is generated, and then grease reagent is added. Upon addition of grease reagent, later the blank solution is to be added with phosphate buffer saline solution, and we need to incubate this for 30 degrees for 2 hours. This incubation generates nitric oxide into the test tube because sodium nitroprusside is there, water is there, so it leads to generation of nitric oxide. Now, these test tubes, when during their incubation period, they can come in contact with oxygen. See, oxygen comes in, and this oxygen is able to oxidize the solution. So, if your test tube has antioxidants in them, these antioxidants are able to kick off the oxygens. In case of sample, we have suppose less amount of antioxidant, less oxygen will be thrown out. Whereas in case of standard, here you can find more and more amount of oxygen getting out. Thereby, different color solutions will be formed in the test tube. Now, since in the control test tube there was no antioxidant, so it has given rise to a very dark colored solution. In case of sample, since we had less intensity or low potential of antioxidant, it has given certain dark color, slightly dark color, and in case of standard, it is very less color or colorless. Again, you can notice here, since there is phosphate buffer, there are chances that it may absorb something, some radiation. So these readings are to be subtracted from each of the 3 test tubes. Then read the absorbance at 400, 546 nanometer and put the values in the formula to get the assay scavenging percent scavenging activity. Next, so far we have studied about the antioxidant property, uh, and now we will have a look at the reducing power or reducing ability of our antioxidants. Antioxidants, they are able to reduce also. See, conversion, the principle of this assay is based upon conversion of ferric ions to ferrous ion. That means antioxidants reduce the ferric ions to ferrous one. Reduction will favor the production of green color in this case. Once it is reduced, green colored complex will be formed after reduction. And who is going to reduce it is the antioxidant. Our antioxidants will force these ferric ions to reduce, and they will force the dark reddish color ferric ions to get converted to green color. More the antioxidant, more the green color solution will be formed. Now see here, antioxidants, suppose this is an antioxidant, this is a reducing agent, it is able to reduce this, and it in doing so it itself gets oxidized. Now this kind of reaction is important when you are manufacturing cosmetics. In generally in cosmetics we add sesamol or sesame oil. Sesame oil has sesamol, and sesamol, it functions in this way. It itself gets oxidized and prevents the other compounds of cosmetic from getting oxidized. Ferric ions are converted to ferrous by the antioxidant. Once they are converted to ferrous, they get green color. Required for this activity are phosphate buffer, potassium ferrocyanide, trichloroacetic. This is the detailed mechanism, or sorry, procedure for this process. Uh, Different concentrations of extracts are to be prepared. So suppose in case of sample, we need to take different concentration, 50 microgram, 100, 150, 200 and 250 for standard also. And you can prepare a calibration curve with the help of standard here. Make up the volume to 1 ml with the help of methanol. A test tube with 1 ml of methanol serves as blank, because we know methanol also is able to absorb certain UV radiations. Add 2.5 ml of phosphate buffer, 2.5 ml ferricyanide, potassium ferricyanide, and then incubate it at 50 degree. Then add trichloroacetic acid, centrifuge it, take the upper supernatant layer. To this supernatant, you need to add ferric chloride and water. Now, the moment you add ferric chloride and water to the supernatant, it produces green color. This green color complex is to be the absorbance of this complex is to be measured at 700 nanometer. Into the detail process, see, we have taken three test tubes. One is sample, the another is standard, or which contains BHT or routine, and the third one is the blank. In this, we need to add range of different solutions. Initially, we will be adding, say, suppose 100 microliter of sample. In case of sample, isolated or extracted compound. In case of the standard, we are adding BHT or routine, a solution 100 microliter. Next step is addition of 1 ml of methanol. Methanol is to be added in all the three test tubes. 1 ml methanol is added. Then 2.5 ml of phosphate buffer. Now phosphate buffer is added just to maintain a pH of 7.4. Then potassium ferricyanide is to be added. Now the after addition of these four solutions, we need to incubate them. Incubate at 50 degrees Celsius for 20 minutes. After completion of incubation, add trichloroacetic acid to it. Once you add trichloroacetic acid, the reaction will commence, and now you need to centrifuge it. After centrifugation, you will notice that the tubes will have a sediment or and supernatant. The upper white color is called as supernatant and the lower blue color is sediment. From this, we need to collect only the supernatant. Slowly collect either with the help of pipette or a micro pipette, or slowly you can or even you can use separating funnel for this. The supernatant is collected into append-off tubes, and these append-off tubes are mixed with water and 0.5 molar ferric chloride solution. The moment you add water and ferric chloride, different test tubes are giving different color. Since the blank is not having any antioxidant into it, it will not produce any green color complex. So ferric ions will remain as such. Whereas the standard, since it has more amount of antioxidant, it has converted all the ferric ions into ferrous ions, thereby resulting into production of dark green color complex. As far as sample is concerned, it varies, the color varies. If it is a very strong solution, it will produce dark color. If it is a slightly or moderate kind of antioxidant activity in it, it will produce light green color in that case. Now you need to record the absorbance at 700 nanometer for this. And again, uh, if you look at the absorbance here, the as compared to the previous studies, here the absorbance shoots up. That is, antioxidants, they increase the absorbance in this case. So this is the reason why I have shown a different graphical representation. Absorbance increases in reducing power. Reducing power assay, absorbance increases because it is forming more and more amount of ferrous ions which lead to green color complex formation. Whereas in case of all the previous antioxidant studies, absorbance used to decrease. May it be DPPH free radical, H2O2 free radical or nitric oxide. In all the three cases, absorbance decreases, whereas in case of reducing power assay, it increases.